Alright, so here's something weird. You ever drop an ice cube in your drink and think, why are you floating, you tiny frozen cube of smugness? Like, shouldn't it sink? Rocks sink? My hopes sink? My grades in math definitely sank. But ice floats. Why? Well, buckle up. We're about to explain how a frozen chunk of water manages to defy logic, gravity, and your expectations. All thanks to some nerdy science happening at the molecular level. And no, this isn't a Harry Potter spell, it's just physics. Sorta, kinda. Let's start with water, the OG of all liquids. You drink it, you shower in it, sometimes you even pretend you drink enough of it. Spoiler, you probably don't. Now, water is made up of H2O. That's 2 hydrogen atoms and 1 oxygen atom doing a little atomic group hug. They're constantly moving, bumping into each other, and generally acting like they drank 6 espressos. That's when water's in its liquid state. But here's the twist. As you cool water down, those H2O molecules start to slow their party roll. They begin forming connections, hydrogen bonds, that hold them together. And this is where the magic happens. Instead of packing in tight, like most substances do when they freeze, because cold stuff usually contracts, right? Water goes, nah, I'm going to expand instead. Yep, ice takes up more space than liquid water. That's because when the water molecules freeze, they form this weird open hexagonal structure that's super spaced out. It's like molecular social distancing. The molecules basically lock arms and say, everyone needs their personal space now. And because that ice structure is more spread out, it's less dense. And if there's one thing we remember from high school science besides how to make a potato battery, it's this. Less dense stuff floats on more dense stuff. Boom, science. So yeah, ice floats because frozen water is actually lighter than its liquid version, even though it's technically the same thing. It's like water went to therapy, came back frozen, and said, I need boundaries. But why does this matter? Like, cool, your iced coffee stays cold without drowning in its own cubes. Big deal, right? Actually, yeah, huge deal. Because if ice sank, lakes would freeze from the bottom up. Every winter, fish would get trapped under layers and layers of solid ice, and most aquatic life would just die off, which would kind of ruin sushi night for everyone. But since ice floats, it forms a protective layer on top of the water. That layer insulates the water underneath, keeping it just warm enough for fish and other critters to survive the winter without turning into frozen fish sticks. Nature really nailed this one. Also, fun fact, water is one of the only substances that behaves like this. Most things shrink when they freeze, not water. Water's dramatic. It's like, I'm gonna be solid now, but bigger and lighter, and I'm gonna float. Deal with it. You do you, water. You do you. And that's it. That's why ice floats. Not because it's showing off, not because it's enchanted. Just because of the weird way H2O molecules bond together when they freeze. Less dense equals floaty cube. So the next time someone drops an ice cube in their drink and it floats like a smug little iceberg, look at you casually say, oh, it's just because of hydrogen bonds forming an expanded lattice structure with lower density. Then sip your drink like a genius and walk away. Mic drop. Ice drop. Catch you next time, where we'll probably ruin another simple thing by explaining the science behind it.